So, what are we doing today? We are looking at ways that we represent relationships. Now, what have we learned up until this point? We have learned about variables, and we have learned that different variables can have relationships. For example, I saw in one of your classes, I think it was last week, I saw one of the classes talking about airtime. So, how many minutes was your call versus how much the call cost? So, those are two different variables that have a relationship. Why do they have a relationship? The more minutes we spend on the call, the more we are going to pay for that call. So, now that we know we have relationships, we'll also know that in our relationships we can have variables. What do we know about our variables? Let me recap it here quickly. We know that my x variable is what we call our input. It is also our independent variable. We also have our y. Our y is our output, and our y is our dependent variable. What does that mean? And look at me spelling incorrectly. What does it mean if I say our y is my dependent variable? I mean that my value of y is going to depend on what I put in for x. So I hope that all makes sense. I'll all caught up to there. What are we doing today? We're looking at how we can represent these relationships. So how do I represent the relationship between my x and my y variables? First, we are looking at our different types of ways to represent relationships. We have tables. I'm sure we've all done tables before. We have flow diagrams. We've been doing flow diagrams, I'm sure, from grade 1. They've been giving us flow diagrams or spider diagrams, as I know some people call them. We have equations. That might be something a little bit new to us, but I think we should all be familiar with equations by now. And then lastly, we have graphs. So we're going to go through each one of these today, and let's first start off with our tables. So when we are representing our relationships using our tables, what am I doing? Sorry, I'm just putting in a line here to make my table complete. Okay, what am I doing? I know the top of my table, I want to have my x values in. The bottom of my table, I want to have my y values. What does that mean? It means that my x values are all of my independent variables. So the top of my table is going to have all of my independent variables, which makes sense. We want our independent variables to come first. Why? Because we need our independent variable, we need our input to get to finally our y values, which is dependent, which is our output. So let us look at this example over here. We have fabric costs, $12.50 per meter. What are my two variables I have here? I know one of my variables is going to be my total cost. My other variable is going to be my fabric meters that I purchased. Can anybody tell me, you guys can put it in the chat, can anybody tell me what's my independent, what's my dependent, or what's my x, what's my y, what am I going to put where in my table? While I wait for the answers, I'll cheat a little bit and help you guys out. My total cost, how am I going to be able to just calculate my total cost? Nope. My total cost depends on the amount of fabric that I buy. So that means fabric is going to be my independent variable. So I have fabric meters that I've purchased, and once I've purchased my fabric meters, what depends on the amount of fabric that I've purchased? it's going to be my cost in rands. Okay. Guys, my pen literally hates me today. It's randomly scribbling all over the place.
Don't worry, don't worry. We can still see. We can still see as long as we understand. It's a doctor teacher's handwriting.
We'll take it. I'll take it, guys. Okay. So what are we doing now? Now let us pick what I want my inputs to be. Remember, my inputs is independent. I can pick any numbers I like to be my inputs. So let's start us off easy. Let's go with 1, 2, 3. Let's make our life a little bit more difficult. Let's go 5, 10, and then 20. Okay, now let us look how I've now picked all of my inputs. I can pick my inputs as I please because I haven't filled in any inputs for me. So I've picked 1, 2, 3, and then I didn't want to go 4, 5, 6 and make our lives easier. We have to challenge ourselves sometimes, so we went 5, 10, 20. Now, how do I calculate my total cost? This cost over here is not my cost per meter because we know my cost per meter is 12 Rand 50. My cost at the bottom over here is going to be my total cost for the amount of fabric that I bought. If we want to write a rule for that, my output value is going to be my input value, and I don't know why I'm writing it too. My input value is what? My input value is X. And how am I going to calculate my total cost? I'm taking my X, which is my meters of fabric, and I'm going to multiply that by 12 Rand 50. So let us see. This number one, super easy. If I buy 1 meters of fabric, what am I paying? I'm paying 12 Rand 50. If I buy 2 meters of fabric, let us look. I've written my equation on the top over there. My output, my cost is going to be 12 Rand 50 multiplied by the amount of meters that I bought. And how many meters did I buy in this example? It was 2. 12 Rand 50 times 2 is going to be what? That is going to give me a total of 25 Rand. Moving on, let's complete the table. If you guys don't understand, make notes on what you don't understand so I can take your questions as soon as I complete the table. We are moving on to number 3. What am I saying? I'm saying my output, my cost is going to be equal to 12 Rand 50, which is my cost per meter. So it's going to be my cost per meter multiplied by my input of 3. There I'm going to get, let me do the quick math in my head, 37 Rand 50. Come on. Okay, I hope you are all with me. Moving on. Let's calculate my output value when my input is 5. My output is going to be 12 Rand 50 multiplied by 5. What does that give me? That's going to give me a total amount of 50 Rand. Let me just put in my Rand sign there quickly. We have 50 over here. Let's look at 10. Last 2 blocks of our table should be done in no time. Y is going to be 12 Rand 50 times 10. This one is a little bit easy. We all know how to multiply by 10. I'm assuming that's going to give me 125 Rand over here. And 20, there we go, 12 Rand 50 multiplied by 20. That is going to give me just double what I had here by 10. And that is going to be 250 Rand. Okay, guys, we have just completed our first table that is representing our relationship between our fabric and our total cost. How did we do that? We put my independent variable, which was my x, in this example, which was my fabric, on the top of my table in the first row. The second row, we put our dependent variable. That is going to be our y value. In this example, it was our total cost. And then we just multiplied my input by my total cost per meter to get my total cost for the amount of meters that I have bought. I hope this makes sense to everybody. If you are good, please pop us an emoji in the chat. Your favorite emoji. If you're not good, maybe put in a thumbs down. I see a raised hand. Ompa, I'm going to ask you to unmute and you can tell me your question.
Ma'am.
Hi.
Hello, ma'am. Ma'am, 5 times multiplied by 12.50 rand is 62.5, ma'am.
I make a mistake. Let me get my calculator out as well. I was doing the maths in my head, guys. So I may have made a mistake. Thank you for that correction. Let me calculate. Okay, 12 rand 50 multiplied by 5. You are so correct. Thank you for that.
Thank you, Mpa, for being wide awake. Teamwork, nice.
There we go. Thank you, thank you, thank you. I know you guys were listening to me there. I know you understand if you are correcting me. Where are we going here? 5, let's erase my answer there. I hope I didn't confuse anybody with that. If anybody has questions, any other questions, or any other corrections, let me know, you guys. Yes, I see a lot of you were correcting me. Thank you for that. Okay, guys, I'm going to move on. I don't see any questions or any emojis, so I'm a little bit left in the dark about where you guys are at. But I know that if you guys don't understand, you will raise your hand or put a question in the chat. There we go. I'm seeing some emojis. Thank you, guys. So this is my table. Tables, quite simple. They actually are all quite simple, but the only thing is you have to get the hang of it. You have to know where my dependent goes, where my independent goes, which is my dependent, which is my independent, what's X, what's Y. We have to know all of that. And once we know all of that, all of my terminology, all of my basics, it's quite easy to put it into a table. Okay, let's go. Our next example. Our next example, we're looking at a pattern. Immediately, I don't like patterns that don't have numbers, so I want to go and I want patterns number 1, 2, and 3. My question is saying to describe in words how the sequence is generated or made from term 1. Now, I know that you guys have done this before. I know that you have done describing patterns in words, but when I looked at all of your questions when you were describing patterns in words, you always had what we called a constant difference, which meant to get from number 1 to number 2, what am I doing? I'm plussing 2 little circles. And to get from 2 to 3, normally when we have a constant difference, this would be x2 as well. But if I look at this, in picture number 2, I have 1, 2, 3 little circles. And in number 3, I have 1, 2, 3, 4, 5, 6. So what did I do here? I actually plus 3. So let's look now. How do I describe in words how the sequence is generated or made from term 1? If anybody has any ideas, feel free to pop your answers in the chat. So if you want to help me answer, raise your hand. We can go through it together. But for now, I'm going to start explaining. So they asked us to describe how we got there from term 1. So I don't have to tell them how we got term 1. They just gave us that. They gave us term 1. So to get from term 1 to term 2, I plus 2. But I can't really describe this pattern as saying to get from one term to the next term, I plus 2. Because I can see from 2 to 3, that's not going to work. If I plus 2, I'm not going to get the same pattern. So let's look at what actually is happening. I'm plussing 2, and then I'm plussing 3. In my next diagram, I can bet I'm going to plus 4. What do we know about these numbers? 2, 3, 4. When I start counting like that, what do we know? What's the word that rings in our head, or at least in my head? It is consecutive numbers. Consecutive numbers. Consecutive numbers are just numbers that follow one after each other. So I can see here, my rule is actually not adding 2. It's not adding 3. It's not adding 4. My rule is to add consecutive numbers. But we're not just adding consecutive numbers. We are adding consecutive numbers starting with 2. So let's see how I would describe this. I would say to get the next terms from term 1, we add consecutive numbers, but I can't just say adding consecutive numbers, because from where are we adding consecutive numbers? Consecutive numbers can be 20, 21, 22. So I have to give a starting point for my consecutive numbers. So we add consecutive numbers, but we are starting with, what are we starting with? We are starting with 2. Let me read the sentence as a whole now. To get the next terms from term 1, we add consecutive numbers starting with 2. What does consecutive numbers mean? It just means our counting numbers. So if I start with 2, I'm going to go 2, 3, 4, 5, 6 until I get to my term infinity. Okay, I hope this made sense to everybody. And let's just draw in our term number 4 over here really quickly. 1, 2, 3, 4. Guys, we're going to act like I have perfect little circles over here. There we go. That would be my term 4. How did I get term 4? I took my pattern number 3 over here, which was this initial little pyramid over here. I took that and I added these last 4 circles, which makes sense because I said that my rule to get from 3 to 4 was just going to be to add 4 little circles. So moving on, let us complete the table really quickly. Let me put in a line as well. Can you guys tell me what's going to be in the top, what's going to be in the bottom, what is dependent, what is independent? Anybody can tell me? That would be great. What are my 2 variables? My 2 variables are my term numbers and my number of dots. So what do I think? I think my number of dots depend on the term number I'm at. So that means my number of dots is going to be my y, and my term number is going to be my x. Cool. So term number 1, 2, 3, 4, 5, 6, and 7. Number of dots, let's scroll back up quickly. Let's check. In term 1, we had 1 dot. In term 2, how many dots did we have? 1, 2, 3. We had 3 little dots. In term 3, we had 1, 2, 3, 4, 5, 6. 6 little dots. And in my lovely drawing of term 4, we have 6, 7, 8, 9, 10. We have 10 dots. Now, how do I fill in the missing ones that I don't have pictures for? That's not so hard. Why? Because we've already written out what our rule is. My rule was to add consecutive numbers starting with 2, which means from here to here, I started with 2, add 3, add 4. My class got a little bit dislocated. From term 4 to term 5, what am I doing? I'm adding my next consecutive number. And I'm just going to go on adding my consecutive numbers. And that is going to be how I fill in my table. Let's change my colors back. 10 plus 5, 15, 15 plus 6, 21, 21 plus 7, 28. And I see we have answers in the chat. Thank you. 28. Great. You guys all got that correct. Well done. So this is now representing my relationship with my term number and my number of dots in a table. Do we all understand? Are we all with me? Please let me know, you guys. Put an emoji in the chat if you are with us. Raise your hand if you have a question before I move on to flow diagrams. Great, I see a thumbs up. I'm not seeing any hands. Let us move on. Okay, the next type of representation of a relationship we're going to look at is a flow diagram. We've all done flow diagrams. If you don't love flow diagrams, I think something might be wrong, because I kid you not, I'm sure we've been doing flow diagrams from grade 1. Grade 1, we have been doing flow diagrams. So this should be easy peasy for you guys by now. How do we use flow diagrams? Flow diagrams, on my left-hand side of my flow diagrams, I have my input. My input is going to flow through my diagrams. So whenever you have flow diagrams, just think of that. Your input flows through your diagrams. It goes through the middle, which is where our rule is contained. And once we take our input, we flow it through the rule. On the other side, on our right-hand side, we are going to come out with our output value. So for this one, let us pick some inputs. Let's start 1, 2. Let's go 5, 16, and maybe 73. Just to challenge ourselves a little bit. In this case, where they haven't given you inputs that they have filled in, you can pick any inputs you like. Generally, you would pick the easiest ones, but because we are teaching here, and because I know you guys are so smart, we are not going to pick easy ones for us. I see a question. How do you do the previous example if they gave you term number 20? So you could just continue with our rule of going +2, +3, +4 until you get to term number 20. Or a quicker way, as I thought you meant, a quicker way would be to figure out what the equation of this relationship would be. So you would have to go and do, I'm sure I saw in your previous lessons, you would have to figure out the rule for the pattern. So you would have your Tn is equals to, my gosh, I cannot recall for the life of me the formula right now. If I'm remembering correctly, I think it is Dn plus C. But when we do this, what you would notice is that D is normally our constant difference. In this case, we didn't have a constant difference. So I don't know if you guys have actually done as yet what we call quadratic equations, where you would have to use one of those to calculate what your equation of your relationship would be.
Yeah, so teacher Simone is really good at maths, guys, because she's ahead of us. Of course, grade 8, we haven't done the quadratic formula, because grade 8, I'm
That
sure
is
they
what I
don't do
thought.
they don't do the quadratic formula, but yes, definitely they will see it. They will see it soon in their life of mathematics.
They will see it and never forget it. But
Yeah.
like I said, you guys,
Them with necessary skills.
Like I said, you guys have not learned that as yet in grade 8. So they wouldn't ask you to do such a far away term. If they did ask you to do a far away term, it would probably be one that had a constant difference where you could work out your equation and then use your equation to quickly calculate what your answer would be there. Okay, moving back to our flow diagrams. I've got in my inputs. Let us calculate quickly. Let's figure out here what my equation is. My equation or my flow diagram is telling me I need to take to get to my output firstly. To get to my output, what do I need to do? I need to take my input value, which is x. I need to multiply it by 2, and then I need to add 3. So that's a very easy way of figuring out what your equation is here, guys. Literally look at what the rule is telling you to do and just write it out in numbers, in mathematical terms like you know. Moving on, because I'm sure we all know the answers to these because you guys are too smart. Let us go into our calculations. For number 1, what are we doing? I'm saying to get to my output value, I need to take 2, multiply it by 1, plus 3. 2 multiplied by 1, 3 plus 3 is going to give me 6. Did I? Yeah. Something is not, 2 times 1 is 2. 2 plus 3, there we go, not multiplied by 3. We didn't
So
multiply by 3, you guys. We added 3. So correction,
yeah.
2 times 3, 2 plus 3 gives us
Yeah. And my people are wide awake also. So I can see on the charts. They're like,
I
ma'am,
see, I
ma'am.
see. Thank you guys for being so observant and awake today. Next one, you guys all seem to be ahead of me. Let's go through this quickly. I'm taking my input, which was 2. I'm multiplying it by 2. I'm adding 3. 2 times 2 is 4. 4 plus 3 gives me 7. Next one, let's do it on the top here. I have, what is my input? I have 5 as my input. So I'm taking 2. I'm multiplying it by my input, which was 5. And then I'm going to add 3. 10 plus 3, 13. Let us write that in quickly. Next one, I have my input of 16. 2 times 16 is what? 2 times 16 is going to give me 32. Plus 3 is going to give me 35. Let us see. Okay, no more corrections in the chat. I seem to be on the right track. 35 over here. And the last one, you guys. Our difficult one, not really, it's still 2 times tables. So 2 times 73 plus 3. I just want to fix my 2. It looks horrendous. Okay, 2 times 73 plus 3. 2 times 70 is 140 plus 2 times 3 is 6, so that's 146 plus 3 is 149. Did anybody in the chat get the same answer as me? Yes, I see 149 somewhere in there. 149. Cool. So those are now representing my relationships using flow diagrams. So where's my inputs? My inputs are all my x values, that is on the left. My outputs are shown on my right, and my rule is all the way in the middle. Okay, moving on, next flow diagram. I almost want to hide our brain break. Okay, let us hide our brain break. We're almost there, guys. What did I just do? There we go. Now, here they've given us inputs. So they made our lives easy. They chose us super, super easy numbers. Let us look at what I'm going to do. They're telling me I need to take my input. I need to multiply it by 2. I need to plus 1. And then, what am I doing? Once I've done that, I'm multiplying all of that, what I've done so far, by 2. I see lots of answers coming in the chat. Thank you guys for being so participative. Participative, is that a word? Where are we? Let's check what we're doing. I'm saying to get my output value, what is my output? My output is y. To get my output value, I have to take my input, which was 1. I have to multiply it by 2. I then need to add 1. And to all of that, I need to multiply 2. So let's look at that. 1 times 2 is 2. 2 plus 1, we're plussing out, almost said multiplication again. But 2 plus 1 is going to be 3, and 3 times 2 is going to give me 6. Did I do that correctly? 1 times 2 is 2, 2 plus 1 is 3. Yes, I do get 6. Yeah, I see answers in the chat as well. Correct stuff, you guys. So I hope how I've set this up makes sense. I don't really want to go into what the equation is as yet, so I don't confuse you guys. But if you set it up like this is perfectly okay as well. If you are super, super smart and you've already figured out what the equation is, that is 100% okay as well. My next input, I have my next input as 2. So what am I doing? 2 multiplied by 2 plus 1 times 2. 2 times 2 is 4, 5, and 10. So let's go in 6, 10. What else am I doing? Let us do our next one. My next input was 3, so I'm going to say y equals to 3 times 2 plus 1 times 2. Again, guys, very repetitive. Once you've done the first one, you're basically just repeating it all over again with different inputs. So 3 times 2 is 6, 7, 14. And then we have our input of 4 times 2 plus 1 multiplied by 2. 4 times 2, 8 plus 1, 9 times 2, 18. And let's do our last one at the bottom here. Y is equals to 5 times 2 plus 1. And then I multiply by 2. I'm just following my rule and putting my input in, and I'm calculating what my output is going to be. 5 times 2 is 10 plus 1, 11. And 11 times 2 is 22. So well done to those of you who got it in the chat. I see a lot of answers in the chat. 6, 10, 14, 18, and 22. Okay, guys, let us move on to a very quick brain break. I do think we have some time for that. Yes, you guys see the joke? I thought that the joke was so smart, actually. A lot of examples. I kind of hate egg puns, but when it's maths related, I love it. So that was really nice. Okay, teacher Yolanda tells me you guys have competitions to see who does the brain break first. So
Yes. Let's see. Let's go, my peeps. Let's see who gets it first. Who gets the correct answer first? Remember, we are looking at the final answer, the question mark. What is the question mark? Nope, I don't think it's 216. Nope, no potato. Try again. Remember, there's some tricks that they put to just throw you off. So look at those tricks and calculate again. You're close, you're close, you're close, you're close. Do I even remember the number myself? But I think I'll remember. But no, the joke. Yes, the joke is quite good. I agree. The joke is quite good. Let's go, my peeps. You guys can do this. Nope, 648 is not. Will guys calculate again? Take it step by step, guys. It's like doing algebra. You need to find out what is the bowl of salad, what is the bowl of the biscuits there, what is the bowl of the donuts, the number of the donuts, And then at the end, you can calculate. Nope, not to 18, no. No. Maybe I might have to recalculate again, but I don't think it's the same. The number, do you still remember, Teacher Simone?
I do.
Yeah, I think I haven't seen it also here. So I also have it in mind what is the correct answer, because we did this the last lesson. So the lesson that we just had now before this class. So I haven't seen the correct answer yet. Let's go, my babes. You guys are normally good at this. You are really normally good at this. So just for my sanity, I'm gonna do the calculations again. Yes, okay. Yeah, none of those answers are there. Nope,
Yeah,
it's not
I
917.
also thought I was going crazy.
Yeah, nope, they haven't gotten the same answer. They haven't gotten the correct answer. Let's go, my people. You need to try. Nope. No,
I
I
do
haven't
see
seen the
the
correct
question
answer.
sorry. I do see the question for screenshots. I did forget to go back last time. As soon as we're done with this break, I'll go back and you guys can take screenshots of what we've done so
It's
far.
not 420. Yes, it is under 500. But remember, it's not guesswork. Lubanzi, it's not guesswork. Nope, it's not 58. Come on, my babes, we can do this. Nope, it's not 215. Are you guys really calculating?
Yeah.
Are you sure you're calculating?
Maybe let's help them out with the first line.
Okay, I'm putting hint. Let's start. What did we get for the bowl of salad? So put the answers for the bowl of salad. Let's go. Okay, perfect. You put the bowl of salad. No, it's not
Great.
230. Okay, so perfect. Now we know that it's 10. What did we find for the biscuit? Put the answer for the biscuits on the chart. Let's go. Answer for the biscuits. Okay, 8. Perfect. Yes, someone got it. Busisiwe, you are the winner of the night. The answer is 196. Busisiwe, do you want to raise your hand so you can explain to us how did you get 196? Well done. Yes, let me unmute you. So on your side, unmute yourself.
Hi, ma'am.
Hi, hi.
How are you?
We're good, Busisiwe. We're just waiting for your explanation. So let us know, what did you do for the second row and the last row to get 196?
Okay, so for the third row, I said 8 plus 8, which is 16. And then I kept playing around with numbers. So I said 18 minus 16 at first, which got me 64. And then I said 64 divided by 2, which got me 32. And then I said 32 divided by 2 again, which got me 16. And then I kept playing around with the numbers. So first I put an 8 there, and it gave me 72. And then I put a 9, which gave me 80. So I just guessed the number as 9. So the last row, I said 16 plus 9 times 20, which is 196.
There we go. You lost me a little bit with your trial and error, but that's okay. You did trial and error. You played around with it until you got 9. That's okay. So yes, you were right.
Wow, well done, Busisiwe.
Thank you, ma'am.
Okay, well done, guys. Congrats to those of us who got it. Moving on.
Oh, so sorry, Teacher Simone. It looks like we made a mistake over here. We have Zinche saying, "Hi, ma'am. I'm not okay. I got a 196 first, but you ignored my comment."
Oh, no.
Zinche, I am so sorry. I can tell you now that it wasn't intentional. I think maybe when I scrolled, I might have missed that. So I'm so sorry, and congratulations to you. It still means a lot that you got it first, okay? So I apologize. I think that maybe I made a mistake. I don't know. I'm trying to go back to sort of try and prove, but I know that I will waste time. So, but on my side, apologies. Okay, it wasn't done intentionally, really. I just made a mistake of finding the first person who got okay. So sorry about that, Zinhle. I hope you find it in your heart.
Congrats to you. All the acknowledgement.
Yes, exactly. Find it in your heart to forgive us. Next time I'll be like, this is for Zinhle, guys. No one has to do it, but Zinhle will do it. I'll remember that, okay? On Wednesday, I'll see you. Okay, Titi Simone, you can continue.
Okay, guys, if you need to take screenshots, I hope you've already done so of the screen. It's been up for some time now. Next one. Let me scroll down a little bit more. There we go. 5 seconds. 1, 2, 3, 4, 5. Moving on. We need our table over there and our first flow diagram. There you go. Ignore my scribbling here at my +7. I'm so sorry. And the last thing we did, our last flow diagram. Okay, I hope we all have our screenshots. We are moving on now to probably what will be the last representation we look at for the night. We are looking at equations. Equations should be something we are all familiar with by now. You guys should know what we mean when we say X, when we say Y. You should know what we mean when I say the sum of, when I say the quotient of, when I say the product of. I hope you guys all know your maths terminology because this is going to help you so much when it comes to formulating equations from sentences. So how do we do this over here? Remember, we're trying to represent our relationship between our two variables. So when we're representing our relationship, what do we know I want to have? I want to see where my X values are, and I want to see where my Y values are. And I want to see what do I have to do to my X to get to my Y value. So just keep that in mind when we're doing our equations. If you have an equation and you don't have a Y in it, it's not complete. If you have an equation and you don't have an X in it, it's not complete. So let us start and let us look at this sentence. We have to be very mindful of the English, the words that they use, and we have to interpret it into mathematical terms. So over here, they told us the output value. As soon as they say something about output value, what do I know? What does that mean in mathematical terms? I know my output value is my Y value. I see answers in the chat. You guys are breathing ahead. So happy to see that. We have my output value, which is Y. The next thing that they've said is that the output value is something. When you see the word is, what does that make you think of? It makes you think it's equal to. It is that. So it's equal to. Then the next thing we see them talking about the input value. Immediately when I see input value, I think of X. And then the last thing in my sentence over here was just +4, which I know means just a regular add form. So let's see, let me put this into an equation. And as you'll see in my little notes on the top, he so nicely formed out my equation. They told me my output value, which means Y, is. So Y is something, so Y is equal to. What is it equal to? It's equal to my input value, which is X plus 4. And I saw so many of these answers in the chat. Well done, you guys. Let's move on to something a little bit more hard. Just a little bit. So nice once you know your terminology. So immediately I'm reading, I get to the sum. As soon as I see sum, what do I think of? I think of plus. So let me start with doing my equation only. I know I'm going to have the sum of something. Now, what do I know? When I have a sum, it means I'm going to have the sum of one number and another number. So let me keep that in mind now when I'm doing my equation. I know already now there's a sum, but I have to look out for what are the numbers that are inside that sum. So let's look. They said the sum of the input value. What do I know about the input value? My input value is x. So I know one of my numbers that is going to be in my sum is x. Move on, the sum of the input value and 5. Let's screen for that. So I've now identified my two numbers that are part of my sum. So I now have a sum over here. What is my sum? X plus 5. So the sum of those two numbers is multiplied by 3. Pay attention to the English here, guys. Did they say that x is multiplied by 3? No. Did they say 5 is multiplied by 3? No. They said the sum of is multiplied by 3. What does that mean? That means when I multiply by 3, I have to multiply the whole sum. So I'm going to put in my brackets and put in a 3. I've now interpreted this entire sentence, but what did I say at the beginning here? If I don't have an x and a y, my equation is incomplete. I don't have my y in here, so let's complete this quickly. What is this whole little part telling me? It's telling me that that's going to be my output. So my output, which is y, is equals to 3x plus 5. I see some answers in the chat. You guys have it in different orders, which is okay. If I were to multiply this out and make this look more of something of standard form, it would be 3 times x, which is 3x, plus 3 times 5, which is 15. So this would be our final answer. But if you had this over here, that would be correct as well. Okay, I see the answers in the chat. I'm assuming you guys are understanding. If you don't understand, put your hand up. Let's ask questions so that I can do the next one with you. Anybody with question? Teacher Yolanda, another class. Oh, there we go. Finally, a question. Thank you, Londeka. Let me unmute you. Hi.
Londega, I think you can just put your answers also on the chat or your question on the chat because we can't hear you on our side. Okay, so I'm gonna just mute you. You can just put your question on the chat, and then Teacher Simone, you can just continue.
Okay, thank you so much, Teacher Yolanda. We're almost done, you guys.
Yeah, so love. Yeah, I had to come into a realization, Kutimina, that's what I want. But then I also had to realize,
Okay, guys, there we go. What do we have? I have an input value over here. They said the input value. I'm highlighting it because I want to identify all of my mathematical terms. I have an input value. My input value, is it correct if you got y is equal to x plus 5 times 3? It is correct because if you were to multiply all of that out altogether, you would get the same final answer over here that I did of 3x plus 15. Okay, so I want to highlight all of my mathematical terms. Let me try and underline. I have the input value. I have is, but in this case is not, does not mean equal to because they tell me it's multiplied. So what's important here? It's not the is, it's multiplied. What are we multiplying? We're multiplying our input by 3. And then it says, and then, which means what? After we've multiplied our input by 3, we have to subtract 2. Keep in mind, look at when they say and then. And then means after. So you almost want to think you have to have brackets because you have to have your input multiplied by 3 and then all of that must be subtracted by 2. Let's look at what we were to do here when we actually put it in an equation. Would we have brackets? So they say my input value is x. It's multiplied by 3. I know when I'm writing out equations, I don't really have to go multiplied by 3 like this. I could, but we know when we have equations that we're writing out, it's actually easier to just go multiplied by 3 like that. So I have my input value. It is multiplied by 3, and then we subtract 2. So here you can see I didn't really need brackets. But if I were to answer it in this way, if I went 3 times x, then I would have used my brackets there and said minus 2. It wouldn't have really mattered because it's multiplication in here anyway, but the brackets just make it easier to understand. So we have 3x minus 2. Am I done with my equation? What am I missing? I see all your answers in the chat are correct. I'm missing y is equals 2. And last one tells us my output value. Immediately I'm seeing output value. I know that's a mathematical term. I'm seeing is. I'm seeing input value. And I'm seeing squared. What does all of this mean? My output value is y. Is means equals to. Input value is x. And what does square mean? It means we're going to have a little squared thingamabobby on the top over there. We're going to have an exponent of 2. So let's write this out in a nice, neat little equation. We're going to end up with y. Why do we end up with y? Because they've told us our output value is. My output value is y. So y is equals to, my input value is x. And I'm going to square it. So I'm going to have an exponent of 2. And I see all your answers in the chat. You guys were so good and so smart today.